Hello, physical science students. Today's video lesson, we are looking specifically at electrical circuits. So we are looking at standard 10B. We are going to talk about the flow of electrons, the type of circuits, as well as some advantages and disadvantages of our two major types of circuits. Oops. So starting with just what is a circuit? A circuit is a complete path in which electrons can flow. In order for my electrons to flow, I have to have a continuous, uninterrupted path. Now, the essential elements of a basic circuit include a battery, so your power source. It includes some type of a resistor, so a light bulb, a device, so like a radio or a TV or something, and it has to have your wires. So it's got to have the path connecting everything. So we've got our battery, our resistor, and our wires that make up the path. If we break the path, if I cut this wire right here, then the flow of electrons will stop and we won't have a circuit. We won't have a working circuit. Now, there are some other items that you might find in a circuit. There are things that protect the circuit from overheating or from failing. We see these in things like automobiles or in your house. So fuses you will find in many electrical equipments. Circuit breaker is something that you'll find at home. These are all things that will trip or break anytime they overheat, and this saves the device from destroying itself. Other things you might find are control devices. This basically allows you to turn on, turn off the circuits. Think of a power switch. Other things such as a transistor or a relay allows you to turn on and turn off the flow of electrons. And I just realized that we don't have the typical switch shown here, but usually switches are shown something like that with the bar up and down. So that up part implies open, and oh crap sauce, down implies closed. And closed is good. That means the electrons can flow. Open is bad. The electrons cannot flow. Coming up in just a second. So notice in the top picture, my wire is broken right here. There's no way for the electrons to get from one place to the other. This is an open circuit. My pathway is broken. Closed, we have connected or replaced that battery, that wire. So now we actually have the connection from the battery to the wire. It is interesting to note that my current is flowing from the negative side to the positive side of the battery. Now, circuits rely on generators at power plants to reproduce the voltage difference across the outlet. So think about things that you plug in. This causes the charge to move within the circuit is complete. So we have two types of circuits that you encounter on a daily basis. One is series circuit, the second is parallel circuit. So these are things that rely on electricity to function. So, a series circuit. A series circuit is where things are connected in only one loop. There is only one path for the electrons to flow. You can have multiple resistors, so multiple light bulbs. Like each one of these little light bulbs is a resistor. But when you look at the wire, there's only one flow of electrons. This thing at the bottom is a switch. So with it being up as it is right now, it's off. It's an open switch. No electrons are going to flow. But if we push it down, we would have the current flowing from the negative, to the positive. So, many older Christmas lights are on a series circuit. If one bulb breaks and the whole strand goes dead, that is a great example of a series circuit. The thing about a series circuit is it provides only one path for the electrons to follow. So if there's any break in the path, the electrons stop flowing and everything breaks. So any damage, whether it be a bulb that is blown or a wire that is broke, means that my electricity is not going to flow. Additionally, if you add more bulbs, so if we add more resistors, it reduces the flow of current, so the lights become dimmer. So assuming the battery is the same in my two pictures, the pictures on the left would be brighter than the one on the right. Again, assuming the batteries are the same. I know they may not look the same in the picture, but let's assume both of these are 2 volt battery. So the ones on the right with the 3 bulbs is going to be dimmer than the ones on the left with just the 2 bulbs. And if I had only one bulb, one resistor, it would be the brightest. So the same current flows through each part of the series circuit. That means the total resistance of a series circuit is equal to the sum of the individual resistors. So if each one of these resistors was 1 ohm, then the total resistance in this particular circuit would be 3 ohms. Because that electricity has to go through all 3 of them, so we have to combine the resistance together. They add together. Now there are some advantages of a series circuit. The batteries tend to last longer because the total resistance is higher, so you're going to have less voltage being able to transfer at any time. Series circuits don't overheat easily. This makes them very useful for something that you might have near a flammable substance, like plants, Christmas tree, or cloth. And series circuits are easy to learn and make. They're very, very simple to make. Their simple design makes it so that anybody, for the most part, can build a series circuit. Take a battery and a couple pieces of Christmas lights and attach it to it, and you've got a simple series circuit. Now, what are the problems with a series? Well, one problem we kind of already mentioned, the fact that if you add more bulbs, the lights get dimmer. So if I hook too many Christmas lights together, I'm not going to see them lit up because there's too much resistance. The other downside is that if one bulb goes out, the whole strand doesn't work. Now, many newer Christmas lights have fixed this problem, but it still happens with series circuits. If this bulb dies, it's dead, then this bulb won't light up because the electricity is not able to flow through the dead light bulb. So our other type of circuit is parallel circuits. Parallel circuits contain more than one branch for the electrons to flow. So 2 or more branches for the currents. The nice thing about parallel circuits is individual parts can be turned off without affecting the entire circuit. This is the type of wiring that you have in your house or in schools or in other buildings. We can turn the electricity off to certain rooms without affecting the current in other rooms. So a parallel circuit, there are different branches different parts of the circuit on separate branches. This bottom, or this thing at the bottom, is trying to represent the battery. And notice this particular illustration, I've got 3 different paths that my electrons could take. They could go this path and light up just the bulb 1 or resistor 1. They could go this path and light up resistor 2. And then they could go this path to light up resistor 3. So the nice thing is, if I were to come in and break this wire right here, it would not affect resistors 1 and 2. So light bulbs 1 and 2 would still light up. And because the electrons are flowing through each path individually, the brightness remains the same. So in theory, I could have as many bulbs as I wanted to on this, and they would all be equally as bright. Adding more does not decrease the brightness. I could add switches to each individual branch so that I could turn them on and off. So think of this as like your bedroom, the kitchen, and the bathroom. I don't know. Each one of those have their own little switch where they can turn the power on and off to their respective lights in the room. And remember, lights are just one type of a resistor. So parallel circuits, the more paths, the less the resistance. So my resistance decreases as we add more paths. This kind of makes sense if you think of it in terms of allergies. In terms of water. If I've got more pipes coming off the same tank, I'm able to get the same amount of water out of all the tanks, but I'm able to get more water total. So the more paths, the less the resistance. So resistance decreases, my current, unfortunately, increases. So I've got more electrons flowing because that resistance decreases. So resistance goes down, current goes up. They are inversely proportional. Now, what are some advantages to parallel circuits? Well, some advantages are that you can have more devices in the circuit. You're actually able to operate and run more things off of that one loop or loops of wire. Also, it does not decrease the current. The bulbs don't get dimmer. If one of the resistor breaks, the others don't go out. Now, here are some problems. So, the currents don't stay the same for the entire circuit. That means the electricity or the energy is used up quicker. The more lights you have on, the more electricity you're going to use. So, the total current increases. The faster the electrons move, the hotter your wire gets. The hotter wire gets, you could have a fire. So, I mean, in theory, I could connect infinite things to one outlet. But you're going to get to a point where that outlet will overheat and will catch on fire. There's a reason why there's only 2 plugs in the outlet. 2 quick illustrations side by side, series per circuit versus parallel circuits. Remember, these little resistors, they could be light bulbs, they could be phones, TVs, anything that runs off of electricity. Anywhere you see a positive and a negative, that is representing your battery. And they are showing that the current flows from the negative through the positive. So make certain you're able to identify if a circuit is series or parallel. It's not the number of resistors, it's the number of paths for the electrons to flow. That is it for today. Make certain you do complete the practice assignment in Google Classroom. And as always, I'm available in my office hours if you should have any questions.